But welcome to my talk. I didn't like my title to begin with, but you know, it says what I'm talking about, so that's enough, right? My name's Joe. A little bit about me. I attended college at Central Washington University, where I studied under Keith Lewis. He's the reason that I'm here today, and I really need to call him more often. I learned all the basic non-ferrous stuff. I always feel like I have to give the qualifications for being here, since I don't really work with metal anymore. I mean, I still can. I know how to do it. I learned all the basic stuff: form and surface, casting, enameling. I'll show you a couple of my metal pieces later. I began working with neoprene in one of my advanced classes. It's pretty much all I do now, except for a few requests that I get every now and then. Such as my wedding set. I just got married in January, moved in with my wife, and now live in Portland, Oregon. I'm very happy about that. There's this rumor going around about artists who live in Portland, and I haven't lived there very long, so I just want to point out that I don't put birds on things. If you don't get that joke, look up Portlandia. It's really funny. In my effort of no assumptions, I wanted to explain a little bit about neoprene. I didn't realize that Megan would be talking about it in her in her demo. So this is a little bit of repetitive, but my neoprene is different from her neoprene. She uses the flat sheet that was originally invented as a substitute for rubber. Was too soft, so it got other industrial uses. I use foamed neoprene. It's a closed cell foam, which means it doesn't absorb liquids. In fact, it's actually chemically inert and doesn't really absorb anything. It doesn't really react with other materials. It also comes in a variety of densities. I use the most robust density, the densest density that you can get commercially. Because of these properties and others, it has a broad array of applications. Some that you're familiar with are wetsuits, hip waders, laptop cases, and I found mine from a culvert gasket. If you don't know what that means, ask me later. In this talk, this also could have been goals of my talk. I want to cover a lot of ground. It's really basic stuff. I'm really excited about what I do. Hopefully you'll understand where I'm coming from with a lot of this stuff, but it's there's no specific technique to what I do. It's all really simple stuff. It's stuff that I think if you guys sat down with some material that you really liked and found really intriguing, I think that you could probably come up with just about everything I'm going to talk about. But since my goal in this talk is to get other people working with alternative materials, there's no point in having other people reinvent the wheel that I discovered. I think the techniques that I use are not the important thing, it's my application of them. So hopefully you'll kind of get an insight as to how I work. Pretty simple. My talk is about a different approach to making with alternative materials. I am advocating use of alternative materials as your prime modes of creation rather than relying on metal. There's nothing wrong with building a structure out of metal and putting some other substance on it, some other compound as an ornament to prove a point or conceptually or something like that. I'm not saying that's wrong. I'm just saying that limitation inspires creativity, and if you limit yourself to one material that is a little bit different than the industry standard, for lack of a better term, you might be able to come up with some really weird crap, like I have. And the way that I do that, the way that I started my work is by embracing the properties of my found material, and it's really informed the way that I make. And I'm still discovering what I can do and the boundaries I can push, and I've been working with this stuff for, help me out, 2 years, 3 years, something like that. So it's been a while. Janae was in grad school while I was in undergrad, so she's been with me since the beginning. I already covered that point. Another thing that I talk about, or that I advocate, is practicing slight variations in what you do. If you find one formula that works, maybe it's not the best formula. Maybe it's just a good starting off point. So you can get a lot of variety. Just by changing one or two little things. Think of, there's probably not a lot of chemists in the audience tonight, but if you're mixing some solution that requires, very careful measurement, if you're off by a couple milliliters of one chemical or another, you'll get an entirely different compound. Different side of the coin, if your DNA was off by 1%, you'd be a dolphin, So there's different formulas can give you a lot of different results. I really feel like I should have taken this out of my PowerPoint, this point, because it's really redundant. What I mean by incorporating design considerations into construction methods is it kind of goes back to the second point here, but what I really meant to touch on with this point, and hopefully I'll get to today, I forgot to yesterday, so you guys get kind of a refined talk today, so lucky you. Is availability is really a big issue when you're using found materials, alternative materials. So if you have a material that you're really stricken by, but you only have like the bits and pieces you found in an alley or walking along the street from point A to point B, then you've got to be really careful about that. If you found a big wide sheet, like I was lucky enough to do, you have a little bit more license to experiment with it. So there's some ways that you can use small bits and really get some mileage out of them. Last serious point on this slide is that the apparent or inherent use for a material might just be the least creative. The plastic used in a milk jug, I've got what I need. I remembered why I need my scissors. Little trick. So if nothing else, this is maybe why you should listen to me. So ordinary piece of paper was supposed to be a 4x6 note card. But I can cut a hole in this in such a way that it can fit around a person. All right. Basically, my point with doing this exercise is to waste time so you don't feel jilted. Actually, my point is very simple. It's one that you're probably going to get tired of me saying, is that the way you find something is shouldn't be the end-all and be-all of that object, which is kind of a point that I am definitely not the first person to make. And Lord knows steampunk artists really hit that home. And I really want you to just consider value in everyday objects that you might take for granted. I think that if you just sit down with something that you're curious about, and this is easier with a note card because it's thicker and it doesn't wiggle around so much. Oh no, I just ruined it. I think I can still prove my point. Maybe I should just skip it. What do you guys think? No. Just keep going? All right. All right. All right. You kind of get the point, right? It was supposed to be anyway. All right. So again, the point is that something that you find that you get excited by has more potential than the sum of its part, or something profound like that. Moving on, how I got here, a little bit of biography? Yeah, autobiography. Everything is a result of my work, so here's a little bit about myself. This is the second wearable art object I ever made. Beginning class, abstract pin, working entirely from sheet. This is 3 different metals. I really loved working with jewelry, but I didn't know it for a year. So beginning class was in spring. My second class was also in spring the next year. And I really liked working with sheet, and I really liked pushing the boundaries of what I could do with sheet. This mask was made out of 20 gauge metal, and I really wanted to push it as far as I could. it opens up, two identical halves, die forming. Megan talked about it, and I can wear it on my face. And the eyebrow ridges are almost 1 3/4 inches deep at their deepest point, which is really difficult to do right near the edge of a die form. And I found that out 9 times before I actually had a finished piece. But anyway, I loved jewelry, and it just so happened that as I took more classes, I made some more weird stuff, and really enjoyed the concepts and pushing the technical applications of these concepts. And sometimes it didn't really work out the way I thought it would, but it was neat. It really excited me. And when I graduated from working with brass and copper and so on, I started working with sterling. I was really happy because I didn't have to worry about solder so much, and so that made me really happy. And it just so happened that most of the way through my second year as a jewelry student, I finished a project that basically exhausted my silver stock. Within the same week, as I remember it, that the price of sterling jumped from $10 or $11 to about $25 an ounce, and now I really would just like $25 an ounce. And I worked construction during my summers to put myself through school, and on one of my jobs about 1.5 years before this point, I procured some material. It was this black foam stuff. It was in a roll like this big around, 12 to 14 inches high, depending on how you measure it. And I had carried 4 rolls of these around with me from one apartment to the other, and I didn't know why. The gods were with me, apparently. So the price of silver jumped. I didn't want to buy more. I don't support market trends like that. I don't support the current market trends, but talk to me about that later. Get me drunk too. It's really entertaining. And so I took one of these rolls to my professor, Keith Lewis. This is on his page on the school website. I'm going to tell him too, don't worry. So I went to him and I said meekly, because I didn't know why I didn't know what I was after. I went to him in his office and I said, Keith, can I make something out of this? And he looked up from whatever he was doing. I'm sure if Angry Birds was around then, he would have been playing Angry Birds. And he said, I don't know, Joe, can you? And it turns out I could. Within 2 weeks of working with the material, I made this bracelet. Not because I'm really good, because I made a series of very lucky measurements and cuts. And I really, well, I'll explain exactly how I got there in a little bit, but it was a really fun process for me, and I kind of, before I even really thought out my work process with this material, I'd already started it, if that makes any sense. So the lines in this piece are what gave me the form, and I thought to myself after I'd created this, can I do this without the lines in it? And I could. And then I thought, since I'm playing with surface ornamentation, maybe I can use my leather punch to punch holes in it ornamentally, and it worked out great. So if you find those can go out too. And then I thought, well, since I'm making jewelry, it's great to have a matching set. So how about I make a matching necklace to my lined bracelet? And it doesn't hang very well, so it's a collar instead of a necklace. But I did it, and it was really hard because the proportions didn't translate up. That, and I don't really do math, so it was a lot of guessing and failing. I was trying to be lazy, and it ended up costing me more work. And I didn't take notes, so I couldn't reproduce it easily. So I went back to doing the simpler things. And tried carving it. The spikes were really fun and just kind of pathetic. So it's just an example of a failed experiment that I keep around to remind myself of how silly I can be sometimes. And then I got tired of making this form. It was just I was just seeing it too much, and so I went with, at the time, what I thought was a wildly different form. And I made this thing, and I hated it because compared to the bracelets and the collar, it was so structurally unsound, but it photographed really well, and it's very easy reference to historical fashion. And I had finished it right before the end of school, just at that magic point in the year when all the summer shows have their calls going out, and I started submitting all this work to all these shows, and got a few bites, and this is the only one that got bites, and I got really bitter about it. Because I mean, now I appreciate the piece, but at the time I was just like, why does everyone like this one? I like the other ones better, you know. And I apologize for complaining about this. But like I said, I got bitter, and so I decided to make some roughs worth getting attention. And succeeded. I had a lot of fun with these. These actually are a very strong indication of a turning point in my process. These are the first forms that have curved cuts. Before that, everything was straight edge from, again, from sheet. These are also the first forms that actually, I think, really exemplify me trying to push the limits of the structure and the design of what this stuff is capable of. But these didn't go too far because I realized it would be impossible to ship them for a very low cost, and so they only showed in 2 shows, and they are now disassembled because they're very difficult to store as well. So I went back to familiar ground. I just started playing with making different things, and just go ahead and pass those all out at random. Just to see what I could do, and see how I could do it. And now I've actually given myself a personal challenge for as long as I'm working with this material, or maybe working in general. Excuse me. My goal is to see how much I can beat this dead horse, how many different bracelets I can make with this simple form. I even started turning it inside out. There's 2 bracelets that are this form inside out. And so that's something that, that's an exercise that I do when I get in the studio and I've either got no ideas or I've got too many ideas to really start in one spot. So I just sit down and I make one of these cuffs, and I try and make it as different as possible. Some of them more so than the others. Sometimes just a subtle change is all I need to kind of get me going. From here, I was invited to a show in San Francisco at the Velvet Da Vinci for the plastic series, and I had just started doing gold leaf on the materials, 23 karat gold leaf. And these represent another shift in my making, in that these are the first pieces of neoprene work that I did that started with a concept first and then went into production. Everything else was design exercise and then concept tacked on afterwards. So I'm really excited to play with these, and I'm getting bigger and more costumey with my work, and I'm really excited about that, and I'm really excited to experiment with that a little bit more. So how does this relate to you? You got it. Some things to consider. This is kind of a step-by-step approach to working with an alternative material you've never worked with before. Some of it's a little redundant, like I said earlier. I try not to make assumptions, and this is a do as I say, not as I do kind of a thing, and I'll kind of explain that a little bit more later on. But when you get a material that you're really excited about working with, your first line of action is going to be your biggest asset, and that's gathering information on that material. If it's a plastic or a rubber, which is pretty common in a reused material, I also papers and metals, fibers, stuff like that, that's fine. But if it's anything chemically based, especially, try and find out who made it. And if you can get an MSDS, it's a manufacturer safety and data sheet, I think is what that stands for. It tells you what it's made of, whether it's hazardous material, and whether it reacts to certain things. I can't remember exactly everything an MSDS talks about, but it's a very important piece of information to have, especially if you're going to be performing random experiments on this stuff. If you can't find an MSDS, try and identify as safely as possible if there are any materials that this stuff will react to, either positively or negatively, that could be a strong benefit for you when you start making with it. Consider adhesives or solvents, whether they will create fumes that will give you a headache or create fumes that will kill you. These things are important to know, hopefully for obvious reasons. One thing to consider that I didn't put on here that I think is really important is your material heat reactive? Can you soften it up by raising it to a certain temperature and then mold it, let it cool? Is it more flexible when it's cold than when it's warm? Some things do that, I don't know. An easy step to take when you're first trying to figure out information about your material is, how did the original manufacturer prepare it? How did they manipulate it? Are you going to manipulate the same way, or can you do it a different way? Some plastics, were probably cast or molded. Can you grind it up, apply a solvent, and recast it? Can you grind it up, apply a fixative, and spray it onto something? Just more of a mental exercise so you don't have to waste material. And then put yourself on some familiar ground. Compare and contrast your material to something that you're familiar with. I chose the example of metals because I assumed that, I had to make an assumption, I'm sorry, that most people coming here would be familiar at least with working with non-ferrous metals. So just some examples of the properties that you might want to consider is memory. What I mean by that is, if you take a piece of metal and you bend it, it stays bent. It's going to remember that force that was exerted on it. Does it have a limited memory? Can you bend it? Oh no. Can you bend it, and will it hold that bend for a little bit and then return to its normal shape? Or does it not remember what happened to it at all until you crease it? Is it going to be easy for you to use? Is it made in a sheet? Does it come in a sheet? Does it come already manufactured in some configuration that you need to break down and figure out how you're going to use that? And we're all used to soldering, so how can you use your material in a way that's similar to soldering? Are you going to use adhesives? What metalsmithing techniques can be applied? Just sit down at your bench and look at your material, compare it to your tools. I wouldn't advise applying it to your tools until you've really thought this out. It's going to be very important to you to figure out what your tools are going to do to your material and what your material is going to do to your tools. We all pay a pretty penny for our tools, and we need to keep them around a long time. So something really innocuous you might think that it's not going to do anything to your tools, but in actuality, you find a problem. If you need to test it on a file, go to the hardware store and get a cheap file before you put your gros base on it, or Friedrich-Dieks, whichever camp you're in. And a lot of times, if you put yourself on that familiar ground of working with metal, you might be disheartened by working with a material that is relatively flimsy. Working with paper. There was a guy, probably a long time ago, I didn't really do a lot of research on this, who wanted to develop some sturdy packaging, and so he took one piece of paper and he laid it flat on a surface. He took another piece of paper, he corrugated it, fastened that to the first sheet, took another piece and fastened that to the top of the corrugation, and we have cardboard that we all use every single day. Try and go a day without using cardboard or anything that's been packaged in cardboard. So there are many ways to do that. Corrugation, applying a curve to a piece of paper gives it a lot sturdier configuration than just by itself. Maybe wrapping something up in tubes and fixing that to some sort of backing so you have a structure for a sheet. If your material is relatively brittle, maybe casting it in with a substructure. Concrete is cast around rebar for a reason. It allows it it allows it to be used a lot easier. I don't work a lot with things that are too robust to be worked with in a studio, but something to consider is woodworkers, like a drum maker, for example, or wicker furniture makers. They prepare their wood by either soaking it in water or steaming it. And then after it's been soaked or steamed for a certain amount of time, the wood is a lot more pliable and easier to manipulate. So they take it out, they work it, and then fasten it, and it's done. You can also, if you have a thicker material, actually this kind of works both ways. If you can alter the thickness of your material, you might be able to either build strength or give flexibility. Just like scoring a piece of metal to get that sharp crease. If you scored a piece of wood, you can bend it and get a really nice curve out of it without having to soak it in water. And the same thing with making things thicker. Neri Oxman, 2 years ago in Philadelphia, gave a lecture which he mentioned the chair she developed. I'm not sure how to sit on it. I can't remember the name of the chair, but it's a really beautiful chair. Neri Oxman, you'll see the picture. And the thickness of the material, it's either thickness or density, corresponds with the pressure points of where a person sits on it. I thought that was a really neat idea. So that's something that maybe you can think about when you're working with your material. And then, of course, how are you going to attach this material to itself and to other stuff? If you're going to make something out of it, you're going to have some way of attaching. So I use cold connections, no adhesives. That's just the way I prefer to work. I don't know. I'm a purist. That's my excuse. Eventually, someday, I might use adhesives, but I think cold connections, that limitation inspires some interesting directions for me to go, some interesting design considerations. But adhesives are fine, especially with thinner materials, I think. Where to look for new ideas about forms? We're jewelers and metalsmiths. We've got a rich history to look at, but what about industry? The Industrial Revolution, modern machinery, there's some really interesting forms and connections that have been developed in the last couple hundred years that I think can really inform the way someone works in alternative materials. The textile industry, that I think is something that's often overlooked in alternative materials. I take darts out of my material to manipulate it, and that allows me to form a wide variety of curves. And compound curves. I can't get compound curves in my work without darting. And I learned the names of those compound curves today in Cynthia and oh my gosh, I just had a brain fart. Betty, I apologize. Cynthia and Betty's workshop today. And you know, if you can do that with your material, more power to you. I support that, but sit and push it. That's basically where I leave you with that with that slide. Hopefully, I'll remember to come back to those points as I'm talking, but no promises. Keep them in front of you. Now I'm going to take you on the journey of how I first started. How I first started making these bracelets. What I did after Keith said, "I don't know, can you?" So I took my material down to the studio when Keith said that, and I waited until no one else was in the studio to do this because I didn't want to get in trouble. And I took a chunk of my foam and I just took it to all our facilities in the. I now can't see anything. I took it through our facilities in the studio, and sometimes I just kind of use the common sense factor of like, is this going to do anything to my material or the equipment? Or I thought, heck, let's just try it, you know. And my bench tools, I kind of figured were lost on this thing. I could saw it, but it was really ugly, and I had no way to file away my saw marks. So that was kind of fruitless. I didn't really bother with any of my other bench tools. I took it around. Can you guys read that? You're not supposed to. Cheaters. I took it around. I didn't try sandblasting. I felt that it had a porous enough texture. I didn't need to retexture it. Made my way to the torch, and I tried it. I'm not going to lie. I didn't know what the heck I was working with, but I tried it anyway, right in front of the fume hood, and I still got some black smoke up in my face. That's why I advocate look at the MSDS first. That's also why I didn't do it around anyone else. I found out some really important stuff by doing that, all right? I found out that this stuff doesn't catch on fire even with a torch next to it. I also found out that if you have a torch next to it and you take the torch away, there's no flame there. So that's neat, kind of. I made my way to the flex shaft. I thought maybe I can carve into it. I could, but it was very difficult to control, and it gave these really nasty burrs that I ended up having to pick off anyway. So that didn't really work. I was able to drill it with reasonable ease. Every once in a while there was some sort of burr or something left over that was really ugly. At that point, when I was drilling it, Janae or Alex caught wind of what I was doing, and they gave me a leather punch, which if you're doing alternative materials, these are pretty cool. I don't think I've ever searched for another substitute for making holes in this stuff. My leather punch is my best friend. And then after I finished with the drill press, our drill press is here and our rolling mill is here. And I thought, well, hey, I'm here already. I might as well throw this stuff through the combination mill and see what happens. And I was originally, for this talk, I was thinking of showing you what I accomplished there and describing it to you, but I don't have a rolling mill anymore and I don't use it. I don't use that technique. But suffice to say, the rolling mill gave me the idea later on for rivets. From the rolling mill, I made my way, still in search of a way to cut this stuff with some measure of control. I made my way to our rubber mold making supplies, and I found a scalpel, and that was fun. I didn't steal the one that we had in the studio. I fought with Janae for it a lot. And I lost a lot because I didn't have the clout that she did in that place. But I use a scalpel to cut everything. And when I was experimenting with the scalpel and the neoprene, I noticed that there's this neat property with the neoprene where I could make a cut into the neoprene, and I couldn't see it after I made it. I thought that's kind of neat. But then if I open it up, I can see it, and that just wowed me. I really liked it. So camera, people, all right. And I really liked that, and so I decided I was going to make a bracelet with that exemplified that property. And so I got to thinking, how am I going to do that? All right, I'm going to need to, number one, make cuts into it, not all the way through, because then I'll just have all these pieces. And I'm going to need some way to keep it bent. And I thought, well, if I keep it bent and I punch holes in the bottoms here, I can just run a rivet through. I can run another piece through, and that should hold it. And so I did that, and I was like, hey, that's really cool. And then I realized that I needed a way, after I had it in that position, I had to create that synclastic curve, right? All right. I had to create that curve to make it wearable. And I struggled with it for a while until Keith came up and said, just cut darts out of it. I'm pretty sure it was his idea. It might have been mine. We'll wait till the history book comes out, I guess. So I cut darts out of it, and I was able to bend it, and I needed a way to bend it, and I thought, well, this stuff isn't like metal. It's, after I run it through and it acts as a rivet, I can still rivet through that rivet. And so I sound like a frog. Rivet. And so that's what I did. That's how I started making that stuff. I laced the rivets together to hold that compound curve. You'll notice when I put the rivets through, this is the first bracelet I ever made, by the way. That's why it's so flimsy. And I cut it too flush, so these have a tendency to want to pull through. And I also laced the inside. I thought it would be more aesthetically pleasing, but every metalsmith that gets a hold of this thing opens it up first thing they do. And so after a while I got tired of struggling by lacing the inside, and I decided to lace the outside, and it really worked out well for me. But now that you know how I define my terms when I work, I'm going to walk you through how I make the bracelet, just to kind of give you an idea of how I make a bracelet. I had a more eloquent way of saying that at one point, and I just forgot it. So first things first, I have a black material that's very difficult to mark on, and my solution was pretty simple. I just apply masking tape to it. Sharpie doesn't show up very well on a black ground, go figure. One thing about this material that you might run into with whatever you're working on, I think I'm going to tackle silicone next, by the way. This stuff is flexible this way, I mean, pretty obviously, but you notice these wrinkles here? It's flexible this way too. So when I was cutting it out of the rolls, I would, of course, use the manufacturer's edge and, try and cut as square as I could. But because this stuff flexed, and I'm sure temperature has an effect on it too, it's very difficult to maintain 4 parallel sides. So what I resorted to doing was making sure I had one edge that I knew was freshly cut. Bam, this is my straight edge. And then I did my best find a known square object. At home I use a carpenter square because I work on a much larger scale now. But I take a known square and I make my second cut. And I just trust that those two cuts are going to be my square. So I always mark my starting point. That way I have, whether my whole piece is truly square, I can use the same reference point every time I measure. So I would cut the appropriate sized piece. Forget that corner right now. I certainly did. So I would cut the appropriately sized piece, and then I would spend the time to meticulously measure out where I was going to score, my cuts, and also where I was going to punch my holes, distance-wise. Hold on one sec while I make these words. I really slopped through this yesterday, and I regret doing that. Don't tell the other people. So like I said, you guys are getting way better. Now this time, I'm going to use my square edge and measure from this side. Is my head? Okay, that's fine. And I'm just using that as a reference point for my distances. And then take my straight edge that has no numbers on it because I've used it so much, and connect. I'm not going to go all the way through this, don't worry. It takes me about, as many times as I've made the same form, it still takes me about 3.5 hours to make one bracelet, and that's the simpler style. So we're just going to go and do the 20-minute short version, and I can explain why I chose to make some of the design choices I made. So pretend those are all lined, and then I take my straight edge with numbers on it, and then I measure where my tabs are going to be. I make 2 centimeter tabs that are 2 centimeters apart on the bottom. Not that it matters, because you're not going to recreate this. You're going to do something on your own. That's wonderful. Then my holes that I'm going to punch, and then the tops of my tabs. And then, again, the whole thing, let's pretend. And then I take my straight edge and pile up. Basically, I'd go through the art building when I first started doing this. I stole every yardstick I could, the thick aluminum ones, and I stacked them on top of each other. I think at one point I had them all taped together. That didn't go over well. I stacked them on top of each other, so right now, very obviously, the scalpel is much longer than the piece of foam is. and I stacked them so that the scalpel could only penetrate, half the way through. And then I scored my cuts. These first ones are actually on. So I just scored them, and I tried to keep the blade as perpendicular as I could. With a thicker material, that's something that's really important, and I'll touch on that a little bit more later. So I scored all 7 cuts for my original bracelet, and then I took my straight edge and I cut all of my tabs out. And for my tabs, I took advantage of that bias. Because remember when y'all made your first band ring from a sheet of metal? You had to take into account the thickness of the material. Same thing applies, especially when you're doing a compound curve. The same thing applies with this stuff. When I bend this stuff into the form, well, hold on. First, let me show you what the cuts look like. So, see, the last guys, they didn't get to see me actually pull it apart because I wanted to have it for you guys. Because I knew how special this group would be. So I pull everything out. There's undoubtedly some little tab or something that's left, and then I get these little guys from punching my holes. For some reason, the way this mechanism works, it leaves just the tiniest little tab at the bottom of the material. For leather, I'm sure it doesn't do that. But see, I get these little guys, and I just rip them off. That gives me my hole all the way through. Yay! And so what I'm left with is this guy right here. You can see it taking shape. I've got my tabs that I'm going to rivet together, in a manner of speaking. And the riveting process with a material that expands and contracts on its own is significantly easier and less delicate than non-ferrous metals. You take a pair of pliers, shove them unceremoniously through the hole, open them like a little bird's mouth, feed them the worm that is your rivet, and pull through. What's that?
Yeah, you put birds on things.
There's no bird in the final project. So then I just, riveted all the way through. One thing I noticed as I pulled the material through is it doesn't fatigue, but it wears. And what I mean by that is the overall integrity of the material doesn't degrade as I pull it through. But because I'm pulling something that's this big through a hole that's that small, there's a lot of friction that happens in that pulling process. And so, I don't know if you guys can see this, but the corner on this piece, this hasn't been pulled through anything, is relatively straight. No focus, right? But this one is actually, it's got a frayed look to it. Because it gets pulled through. And so the more times I would pull this through, the more fatigued it would get, the more I would have to worry about when is it going to break. I sold some bracelets at Snag last year that I'm kind of concerned about this year. I'm going to hear from some people, hey, you sold me a piece of crap. Well, I'll fix it for you. So this is what I end up with. I actually found out that if I rivet like 2 or 3 more of these, it looks kind of like a weird lobster, but no bird there, right? Completely different animal. So here's what I end up with, and you can see the bracelet starting to form. And my elegant solution to keeping it around is to, like I said, rivet the rivets. So this is a little bit more delicate because with the big ones, I'm only going through 2 holes. I'm only distressing it, those 2 times, and then it's done. Then these pieces don't really do anything. But with these ones, I'm going through. The original bracelet had 8 holes, but I'm going through 9. And so this, I've already kind of done this a couple times. I practiced at home before I came. So this slips through a little easier. These middle ones, here, this one. the middle one hasn't been stretched as much, so I really have to, so that's as far as that wants to go. You guys see that in the camera? That's as far as it wants to go through. You see that little bit peeking out? Whereas this one that's already been stretched, you know, it's primed. So there's a lot of friction here. And with these ones, especially when I was doing this through the center, you can imagine I was, number one, it's very difficult to get this tool the further down I got. And the other thing is I was using ones that had a round cross section. So it's very difficult to, number one, see in there. Number two, make sure I was hitting the center of the rivet. So the outside, working them on the outside actually just made it a lot easier for me in so many ways. And so I pull it through in short motions to kind of reduce the amount of fatigue. And I also switch sides. And as you work with the material, you just become aware of its limitations and the way you have to coddle it in order to get it to do what you want. You know, which ways you have to cunningly persuade it to follow form. And then when I first started doing this on the outside, I noticed something that kind of freaked me out with these riveting the rivets, lacing them, I should say. That's what I call it. I'll point it out here in just a minute. So by alternating sides, I give the lace on the other side a chance to relax and revert back to its normal integrity while I'm working on this one. Unfortunately, the neoprene doesn't have that quick a memory, so it's still a little bit fatigued when I come back. I just don't have the patience to go through one, walk away for 20 minutes, come back, and so I just go for it and hope for the best. So before I tighten this up, notice how these two rivets are just leaning towards each other. You know, they really like each other. Really. I'm not used to this camera thing. So they really like each other. And when I first saw that, I was really confused, really concerned, because I didn't want all these rivets to have that effect, that look. And I didn't know what to do about it, and so I figured, well, while I'm thinking about that problem, I'll just keep working. And so I did, hoping that the magical neoprene fairy would come down and teach me a lesson about how to work with neoprene. And what I noticed was the further around the bracelet I got, the more the force was distributed evenly between rivets, and I didn't have to worry about it so much. Can you see that? The way that those center two, they're just kind of sticking straight up now. I always tend to have this problem with the end ones. The solution that I developed is after I lace them all the way through and I trim them, I pull my tabs out so it's less noticeable. And I'll explain that in a minute. So anyway, lace all the way through, and excuse me, this is what I end up with. I usually do these rivets really long like this, so I can cut them. I used to cut them with my scalpel, and this is a fresh blade. I've made one cut with it. But when I'm trimming something right here on a finished bracelet that's going to be photographed and handled, I'm liable to stab it and make a cut that I don't want. Also, look how close my extremely sharp blade that is not sterile but is the same sharpness as a surgical blade is. Look how close that is to my finger. So that made me really nervous for several reasons. So I realized that my flush cutters worked really well, and they also had an added bonus of, oh, that one didn't do it. Hold on. I get such a joy out of doing that. It's so simple. Don't do that with wire. Don't do that with wire. It's much more difficult to take an eye out with neoprene. But I leave all those rivets long. Can you? Am I there? Okay. I leave all the rivets long so I could give them the same height. On this one, I kind of fudged it, and some of them were too short to actually trim appropriately. But there we go. That's essentially how I make my bracelets now. And that's the bracelet we made together. That basically concludes the lion's share of my talk. There's a few really small techniques I want to mention. A lot of them you can find in the Complete Metalsmith, actually. But I want to revisit them in an alternate material in my neoprene. I also cut some chunks of plastic out of some milk jugs. Before I came up here, I was thinking, well, I could show everyone how to do all this stuff in neoprene, and that's really neat. But I work in neoprene. I don't want everyone else working in neoprene. Which, if you do, that's fine. Make it your own. Have fun with it. It only comes in black. I'll tell you that right now. If you want to, that's fine. But I wanted to show that these techniques are applicable in other materials. And so I got all these milk jugs from the coffee shop across the street from me. And I was going to cut out the flat sections and use those to make examples from. But milk jugs now, like the long sides, they're not flat anymore. They've got a dimple in them, and I'm pretty sure that's actually for structural integrity. But I have no research to support that. So the flat pieces I ended up with were really small. But the principle is the same. And is it okay if I'm here, or do you want me over there? Now that I moved everything over there. You can't see. All right. No, that's fine. We can do this. Can you help me clear this off real quick? All right. So I'll name the techniques. You might remember some of the names. The slot and tab. It's a pretty handy one. The dovetail joint is actually a really fun joint to use in alternative materials, and that can be a little confusing. So I'll explain more about that here in a second. And I also use rivets for corners. I need these. So let's start with the big, easy to see ones. I didn't key these right because I didn't think about it before I actually started cutting. I did take the time to measure them properly, though. I didn't do that for the plastic ones. I kind of freehanded it. Usually a woodworker's dovetail joint is a perfect fit, positive and negative. These are not. And I did it for a reason, because I didn't want this to be a flat sheet. I'm not trying to accomplish a flat sheet. That's what I cut these out of. But as a corner, it definitely achieves a very interesting end. Something to consider. I like using that word, consider, ponder. I have a background in philosophy, and that might be why. That also might be why I stuck with a useless degree. No offense to anyone.
If they were cut exact like the woodworker would do, they wouldn't go make a square like this?
I don't believe so, but worth experimenting. And another thing that's a factor with this dovetail is the thickness of the material. So that will adjust whether you need to do it more to an exact positive negative, or you can do it more exaggerated. So get this neat little box, and after I establish a corner, it's actually a relatively stable configuration. But this isn't the only thing I can do with this dovetail. If these pieces were longer, this would make more sense. But any joint you can do in this way, where you've got something flaring out the outside, you can do the other way. This didn't work for me too well yesterday, but there we go. This looks like crap right now because these pieces are really short in comparison to how long the tabs are. But if these walls were a lot longer in proportion to the size of the tabs, there'd be less force being exerted on the dovetail, and there'd be more on the wall, and it would give you a more regular shape. But in a different material, I think it looks better this way. Log cabin look. In a different material, these more ugly. Oh, another thing. Dovetail joints, I discovered this after I cut these, work like a hinge. If you do like odd and even, 3-2, stagger it, you don't get this weird cocking action, the tilt, you can actually get a more square orientation. Write that down if you want. With the shorter, one more thing. I'm progressing, and feel free to ask me questions as I'm doing this, because this is just me rambling and going for filler. It's pretty solid just pulling out, but because it's a softer material, it's only going to take so much force to come apart. But it still takes some effort to take it apart. Now with this plastic, still pretty flexible. The lack of thickness really doesn't give me a lot of stability in that corner until I add all 4 pieces. And they kind of support each other, but not so good with the narrow walls. The same trick applies with this one. It actually works better with the narrower material, or the thinner material. Turning it inside out. I didn't key these pieces very well, I apologize. See, that's what I'm talking about. It gives you a different aesthetic with the narrower material. The other thing is, because this is more rigid on a perpendicular axis, so this axis is pretty flexible, but this axis not so much. The dovetail is actually a lot more stable to pull apart. So that's something to consider with some thinner materials. Another joint, I'll start with the less impressive one. I freehand cut these tabs, and I don't like the way they look. I did them first, and so then I measured my other ones. It's just really boring for me to work in this plastic after working in the neoprene. But I wanted to explain that, I wanted to show that this is applicable across media, not specific to one material. I mean, clearly this stuff is used, you can use it in a metal, so why couldn't you use it in a plastic? So that's a little bit more stable in this thinner material, slot and tab. But it's still got that issue, but, I forgot one thing. Going back. So with my 4 corners, kind of wonky there, but what if I move to 3? Those aren't going anywhere. They're not going to shift against each other. So consider maybe a 3-walled box instead of a 4-walled box. Stuff like that. These slot and tabs, same principle of turning it inside out. It gives you a completely different aesthetic, I think. And it's just as stable. Again, if these were longer, if you exerted the force differently, you could get different curves. Oh, I never thought about this before. What if you had, sorry. So when I had these pieces together, I said, if they were longer, the force would be exerted on the walls and not the edges. But you can control your shape if you have longer walls on one side and shorter walls on the other. No duh. It sounds really dumb and really simple, but the way the force is exerted is the thing that I got really excited about, because it completely changes the way that the force is exerted over the joints in the walls. So you could end up with some really interesting curves just by applying different lengths to different forces to different lengths and over different joints. These pieces keyed differently, rather than having a slot and slot and then a tab tab. I went with the combination. Again, this material is so much more pretty and fun to work with. So I actually measured these ones, and I wanted to illustrate a point with the thickness in these. The thickness ends up being a lot more stable with the slot and tab than it did with the dovetail. It doesn't really like to shift as much as the other one. Also, I realized when I did that last slot and tab that I couldn't make a triangle out of it because I keyed it wrong. But it just playing around with your forms and your designs can really change the way that your structures are made and the way that your forces are applied. With this material, the thickness, turning it inside out, doesn't work too well. I also have a tendency to do that, and I get this weird teardrop shape. It might work for you and your material, I don't know. But playing is a big part of it. What is that? There's a Ken Corey show years ago, and he had a quote about scientists do work disguised as play or something like that. Do you remember? Do you know what I'm talking about? There's a poster on the door of our studio, and it was an advertisement for a Ken Corey show. Anyway, one thing I don't like about the slot and tab with this thicker material is the way the force is exerted on the tab, from the tab to the sheet with the slot, is I get this weird thing. I see the edge of the material, and I don't really like that. But that would be an interesting place for me to maybe put some gold leaf if I were to use this joint. You know, just a little accent. And all right, for my next trick, need a couple of these. So does anyone have any questions, or are you just enthralled with me playing with this random shapes?
Have you tried painting on neoprene?
I have not tried painting it, just because I like the texture and I like the color. I don't really have a good reason why. Because I don't like to paint. That's probably the best reason. And because it's chemically inert, I imagine that it won't bond, but I don't know. Because the gold size actually works pretty well. So.
Or one of the other demos, she flocked some things.
I hate flocking.
Really?
Yeah, I absolutely hate flocking. Flocking can go flock itself. You know what? Some people can flock really well, and I cannot flock really well. Someone asked me another question, or I'm just gonna keep going with this. I have tried felting it, and I'm told that I just used the wrong felt when I did it. So that's something I'm going to revisit because it sounds like fun.
Mean felting the material or using felt?
Using felt into the material, like felting felt to the neoprene.
Yeah.
Is that what you do? You felt?
Felt wool.
You felt wool. Okay. What's that?
With the needle felt.
Yeah, needle felting is what I'm talking about. So watch out. So that's something that I'm going to try pretty soon when I get the time and money.
But the other thing is like it looks almost like, it looks almost like you could use similar techniques with thick felt sheets.
You probably could. I've even tried essentially sewing, using the rivets as stitches, and that had a really interesting effect. I haven't perfected it yet, so I haven't used it for anything. But it's something that I'm going to experiment with a little bit more, especially as my work gets a little bit more costumey. I think it'll give me some interesting results. But there's this weird kind of thing that happens with the edge of the neoprene. The more I rivet along an edge, the more it distorts that edge, because it's expanding every time I put a rivet through it, and so it'll really change the shape of it. And that was an unfortunate thing to learn after I had. Oh, dang it. See, when I do it on purpose, it doesn't work the way I want it to.
Have you ever tried actually sewing to it?
No.
Would that be something that you were interested in?
It's possible. Keith, I don't know why, but he always wanted me to try linen. Was it waxed linen thread? He always wanted me to try waxed linen thread, and I was like, okay, yeah, someday I'll get to it. Whatever.
So don't you know that one, the slot and...
The slot and tab?
How you don't like that piece?
Yeah.
I'm wondering if you cut your slots with the perpendicular.
Yep.
If you put it at an angle, would that be...
I'm sure it would. Yeah. Yeah. So if you have a flexible material, this is essentially, I mean, this is a rivet joint, and it's just bent out to make those walls and make that form. Really simple, but it gives a really dynamic effect to the square. If you flip it around, you know, it gives you a really different effect. And you know, just like those other two examples, the slot and tab and the dovetail, if you played with the length of the wall in the way the force is exerted, you could achieve some really interesting shapes. You know, make them a lot narrower. You know, make the curve a lot longer, stuff like that. Another thing, if you want to turn a corner with a flexible material and a rivet, just leave a little bit of space. Because the way these things work, I mean, I call them rivets, but you know, the reason I do that is because they are wide on one end, skinny in the middle, and fat on the other end. And there I have Mickey Mouse. Or Garfield, I guess. But I've got a different corner, is what I was pointing out originally. The last class told me I had a cartoon character silhouette there. The reason I refer to it as a rivet is because the hole will only expand, the hole that I punch will only expand so much, and the cord that I put through it will only contract so much. And so it accomplishes the same thing as a rivet by being skinny in the middle and fat on either side. That's why I refer to it as a rivet. To me, that's the function that a rivet serves. And I'm lucky enough that with my material, I can achieve that while still having slack on the other side, something that you can't do with a non-ferrous metal. You know, you've got to have a tubing or another sheet or something like that. So it's just, if you can skew the way you think about your metalsmithing techniques, you can apply the same principles to your material. So that's all the monkeying around I have for you. Thank you for listening to me. Any questions? Yes?
You might have said this when I was out today. I had students that are spread out all over the country because of the weather, trying to get in to the conference. Does the neoprene come thinner?
It does. It comes in a wide variety of thicknesses. This just happens to be the thickness that that I started with, and it's the one that I'm used to. And in Philadelphia, when I took it and was lucky enough to have a portfolio review from Boris Bally, he wanted me to make a two-piece suit for him. And if I were to do that, I played with that idea for a while, and if I were to do that, I would definitely have to use significantly thinner material.
I think that wouldn't change the foam as rivet then, right? Relationship?
No. It wouldn't. The way that the foam expands, I think, would change. I would get, right now, the way that the hole expands, it doesn't really affect very much the sheet around it over a broad area, I mean just the immediate area. But I think if I used a thinner foam, I think it would affect a broader area, is my guess. But I don't know for sure. I haven't tried it.
I think it's interesting that this work comes out of your construction background and your family construction and just that whole thought process about your relationships with materials. And I find them to be really powerful black. I can't imagine other materials with them. I think I love work that's simple but clever. So it's all of those things.
Thank you for calling my work clever.
It's smart, it's simple, they're well thought out, and I can't imagine putting other materials with them. I think that would just take away from the form. So I can imagine exploring more forms, but from the peanut gallery back there.
Oh, I appreciate that. Like I said about that series of bracelets, I really, I just want to see how much I can do with the material alone. Like I mentioned, I don't use any adhesives in any of my pieces, and I take a strange pride in that. Someday maybe I'm going to have to do something where I need adhesive, and I can't imagine what that is right now, but I'm excited to find out,
Have you ever looked much at paper artists that do a lot of paper cutting and folding?
I was led in that direction while I was in Cortona, but I never followed it up. because I came back and started paying bills right away. But it's
Thank you so much theirs because a lot of them don't use adhesives. It's all cutting and folding, and the strength that they get from that in the form is really interesting.
and that is definitely something that crossed my mind several times while I was constructing this talk. I didn't feel that I had the necessary background to really speak about it very much because there's so many people that do it so much better.
It's incredible. You just Google like paper folding or paper artwork.
Yeah. Yeah, there's some really neat stuff at the Venice Biennale last year, or 2 years ago. It was really nice. But it's something, it's just another one of those resources to look into. Just another whole other field that can be really inspiring for myself as well as hopefully for you. Any other questions?
I'm sorry, can you laser cut this material?
You probably could. I've never tried. I know that you can water jet. The guy at the machine shop I talked to said you could water cut anything. As long as it wasn't toxic going down the drain. I'm sure you could laser cut it, but I haven't tried. Part of the reason is when I cut, I think I kind of mentioned this and then completely glossed over it. When I cut these tabs out, my natural inclination, because of the way I hold the scalpel, is to cut at an angle. I'm kind of exaggerating here, but it's to cut at an angle. And most of the time I don't like to do that because it looks like a mistake. Like when you're cutting sheet, you want that cut to be really nice and clean. But for these tabs, and this is actually a really bad example, I like that bevel, because what's happening as I fold them in, this material on the inside is moving a lot more than this on the outside, and so by embracing that bevel, I can actually ask it to do a lot more. I did do a couple bracelets that I made that cut a lot straighter, and this is the effect that I got. It was a lot more extreme than this, but I think that would be repeated if I laser cut it. It would be really blown out of proportion. There might come a time where I'll embrace that, but right now,
Or you could even like laser cut patterns into it and then do your cutting.
That would be fun. That would be fun. I've never played with a laser cutter, so maybe someday.
There's one in Seattle for public rental.
Is there? How much is it?
I don't know, but my friends run a fab lab in Seattle. If you're in Seattle, there's a fab lab called Metrics. There's also another one on Capitol Hill that just opened too.
I'll have to look into that.
But there's parameter limitations on it. But I mean, this is pretty soft material.
Yeah.
It cuts acrylic, so.
I never actually got an MSDS for this stuff because the foam shop I started getting it from, the guy assured me that there's nothing hazardous about it, so I don't need an MSDS. And I was just like, oh, okay, no problem. and so I never actually got one. So I don't know what kind of fumes would be created. And that's one thing that really kind of concerns me. But I'm sure there's ways of getting around that. So, anything else? Anyone? Ready for anything? All right, well, thank you very much. Hope you had a great time.